In this exercise, we're asked to suppose that the risk-free zero interest rate with continuous compounding are the ones that we have in the table, and we are asked to calculate the forward interest rates for the second, third, fourth, fifth, and sixth quarters. And the key idea here is to understand that we have one 3-month rate, which is 3%, a 6-month rate, which is 3.2%, and a 9-month rate at 3.4%, and so on and so forth. And what we know is that, so the rate from 0 to 3, the zero rate from 0 to 3, that's 3%. We also know that the rate from 0 to 6, that is 3.2%. But we don't know the rate, this is our unknown, we don't know the rate from 3 to 6, the forward rate from 3 to 6. So let's try to figure that one out. And let's use a little bit of notation. So we have our R1, which is 3%. We have our R2, which is 3.2%. We have our T1, which is, so T1 is 3 months out of 12 years. That's 3 over 12, or 0.25. We have our T2, which is 6 months over 12 in a year, so that's going to be 0.5. And what we need to find out is our forward rate, which I can call F1, and this is what we need to find out. And for the sake of this exercise, we will use continuous compounding, just like Hull does in the textbook, although the street uses discrete compounding, so we will later solve this exercise with discrete compounding. However, so far what we know is that e to the power of R1 T1 times e to the power of our unknown rate, F12, times T2 minus T1 is equal to this guy here, which is e to the power of R2 times 2. And what we need to figure out is this guy here. So let's try to isolate for this guy. And to isolate for this guy, we could take the ln of both sides, so that we have the ln of ER1 T1 times EF12 times T2 minus T1 equal to ln and e, since they are one is the inverse function of the other, we can just be happy to remain with R2 times T2, and we still have something to do right here. Well, we know that the ln of A times B is also equal to the ln of A plus the ln of B, so we can rewrite this as the ln of ER1 T1 plus the ln of EF12 T2 minus T1 equal to R2 T2, and the ln and the natural logarithm function and the exponential function, they cancel each other out, so we are left with R1 T1 plus the same thing on this term, F1 2 times T2 minus T1 is equal to R2 T2. And remember, we still need to solve for this guy here. This is the guy we want to solve for. So first thing we can do is to subtract R1 T1 from both sides. R1 T1 on both sides and be left with, so these two guys are canceling out, which leaves us with F12 times T2 minus T1 equal to R2 times T2 minus R1 times T1. And eventually, to isolate for this guy, we can just divide both sides by T2 minus T1, T2 minus T1. These two will cancel each other out. And we finally have the formula to compute the forward rate between period 1 and 2, which is nothing other than R2 T2 minus R1 T1 over T2 minus T1. So why don't we try and put some numbers, to plug some numbers in. So we know that our R2 was 3.2%, R2 was 3.2%, and T2 was 0.5, 0.5, minus R1 and T1. R1 was 3% and T1 was 0.25. So 3% times 0.25 over T2 is 0.5 minus 0.25. And I'll let you crunch the numbers, but at least you got the intuition and understanding of how and why we compute the forward rate between one period and the other.